The truth is, the universe has no outside at all, and so, me might argue, because he is expanding, that means he must be getting bigger. The challenge is that what expands is not matter, entering a larger space, that it's actually space itself making new space. And so, in the next few minutes, together, we'll go to follow this concept all the way, starting from Harbaugh's red meter TO, the microwave background in the TF snowflake. Starting from the early universe, the size of a beach ball, TO Einstein. It's actually called the error cosmological constant. In the end, you may find what we call the outside. Maybe it's just an illusion that can never be reached. For the abstraction of the expansion of the universe, easier to understand that, let's start with a simple scene analogy. Imagine you're in your living room inflating a balloon. Air is blown in, rubber is stretched, the balloon takes up more space. The reason why he can get bigger, that it's actually because there are still places to go around. Your living room is outside his, and that's why that we are natural. We'll compare the expansion of the universe to the same thing. Space.it seems to be expanding into some larger cosmic room. Because it is getting bigger, there should be boundaries. There should be an end. And that seemed like a reasonable idea, but it just happened to step into a cognitive trap. Physics tells us that. That's not how the universe works. When space is expanding, that it's actually not pushing outward, because there is no such thing as an outside, a container or empty space waiting to be filled. The universe is getting bigger. He is also creating his own space. A better metaphor is that if you want to draw a circle larger than paper, you wouldn't change it for a bigger piece of paper. The idea is to make the paper bigger all at once. To accommodate that line. That sounds awkward. It is because in our daily experience, any expansion has to grow into a plant somewhere, into the air, the expansion of the city into the countryside, ice on the water. Therefore, we unconsciously make sense of the world in terms of the inside, the outside. But if you are both paper and drawings, the concept of outside is meaningless. And so, the question is no longer, where is the universe going? It's actually, how do we know that space itself is growing? The answer comes from the farthest star. Scientists observe distant galaxies. I just realized this counterintuitive fact. Edwin Hubble discovers that the farther away the galaxy is, the faster you move away. At first glanced, it's actually like implying to us, at the center of a cosmic explosion, that it's actually like everything's flying out of here. But here's what's really bizarre. Galaxies don't escape through space, that it's actually that the space between them is stretching, that it's actually much more intuitive to use the metaphor of an inverted balloon. Think of galaxies as points on the surface of a balloon. When the balloon gets bigger, the distance between points increases. The dots don't crawl along the surface. The surface itself is expanding. Each point sees other points moving away, and no point is the center. Put this two-dimensional surface, change to the three-dimensional space we're in. The key conclusion: the universe is not expanding somewhere outward, because there was no outside for him to enter. He grows and creates his own stage. This conclusion not only made the audience head, it also made the geniuses of the year scratch their heads. Even Einstein was initially reluctant to accept. But here's the thing, this seemingly impossible expansion, that it's actually happening at a speed Yotes imagine. And so, here's a hard question to answer. How do we know for sure? It's actually not just a pretty metaphor. The clue lies in the experience of the light being stretched. When a distant galaxy shines light on us, wavelength is determined, whether it's blue light, red light, or infrared. He has his own fingerprints. But when this beam of light, when traveling through an ever-expanding space, the road under my feet will be longer and longer. Imagine you are walking along a path on the automatic trail that will slowly expand. The stride is the same, but the road was quietly elongated. Wait until you reach the end. Actual formation far exceeds the number of steps. For light, it didn't end up going further. It's actually the wavelength that stretched. And so, when the blue light from afar reaches us, turned into red light. Here's the thing. This is not when the ambulance flies by, the Doppler effect where speed changes frequency. It's actually space that gets stretched along the way. Extend the distance between each wave, wind, and trough. This is the cosmological red meter. It directly demonstrates the growth of space, independent of the motion of the objects in it. Let's put it more intuitively. One can take you to the third dimension, the mechanism by which the ruler of the world is getting longer, pulling the wavelength of ancient starlight into a whole new gear. Here's another one. Enough to refresh the quantity set of the three views. Light wavelengths of the most distant observable galaxies. It has been stretched to nearly 40 times its original size. Intense ultraviolet is being pulled all the way to faint infrared. This is equivalent to a journey over billions of years. The size of the universe has also expanded by nearly 40 times. Therefore, you see that galaxy in the telescope, small and dark, but when the light left him, the universe was much smaller than it is today. He's also much closer to the future galaxy. The visible space is not slightly larger, that it's actually a continuous, grand stretch. And here's the thing. This stretch. It didn't happen in some far corner. It was everywhere. And the room was trying to get bigger. The space between your eyes and the screen. I'm also trying to distance myself. The reason why you can't feel it, because of the electromagnetic interaction between atoms. It holds the material in place. Inflation force. Can't look up at all on this scale. Only between galaxies, where this atomic watering is missing, expansion can play freely. Take them farther and farther away. It's actually like leaven dough. Take the raisins with you. The raisins are not actively moving through the dough. It's actually making the dough bigger. And so, you ask, where is the universe expanding? It's actually like asking where the dough is going. Don't forget that you are part of the dough. But since space stretches everywhere, how far can we see? Put it bluntly, we live in an invisible cosmic prison cell. His walls were built by the hands of time. Looking up at the stars at night, you'd think the universe was unfolding before your eyes. But the fact will directly overturn the cognition. You can see it. I'm afraid so. Less than 4% of the real universe. The reason is simple. It was brutal. Limited speed of light. The universe has a limited lifespan. The further you look, it's actually like the longer you go in time. When you look at the sun, you see what you saw 8 minutes ago. If you look at the alpha coefficient of the Centauri, you see it 4 years ago. Look at Andromeda and see 2.50 million years ago. The age of the universe is about 13.80 billion years. In other words, that the oldest light. It took at most 13.80 billion years to reach you. Galaxies longer than this. Starting from your perspective, it doesn't exist, because their light is still on the way. But don't forget, during this time. It keeps expanding. Those distant galaxies. Emitting the light we receive today, much closer to us, waiting for this ancient light to finally arrive. The expansion has taken them 46 billion light years away. And so, our observable universe is a bubble about 46 billion light years in radius. There are more galaxies and stars outside the bubble, even. Perhaps there is another you who is reading this passage. You can't see them, not because they were not there, but because the light didn't arrive in time. And so, the part outside the bubble fall into the unobservable universe. It's actually not a forced barrier. But the laws of physics lie in the rays. You can think of it as a thick layer of fog. Put the business, restricted to a certain distance in any direction. You know there's a world outside, but you can't penetrate. And I'm just going to go one step further. If the universe is close to infinity on a scale, you little observable bubble, percentage of the total. It can almost be written as a nice zero to understand where this wall of time really is. Together, we'll go to look back at one of the oldest lights. The oldest light in the universe today. 600 million miles an hour. Coming towards you. He predates the birth of the solar system. Before the Milky Way was finalized, his journey, because the universe was only 380,000 years old. The universe was a sea of hot plasma. It's actually too hot for atoms to form. No photon can travel more than a few inches. It gets caught by charged particles. The universe continues to expand and cooled to a low enough temperature that it was the first time that protons, electrons combined to form clear source particles. The fog lifted. The universe suddenly became transparent. Light can travel freely. That's the compounding phase. The first photons to escape. That's what we see today. Cosmic microwave background. Radiation, he is everywhere, filling every square inch of space. Even when the old TV is cut, a little bit of snowflake noise that falls out. About 1% comes from this distant light. And here's the thing. He marks the edges of everything we can't see. You can never see beyond this horizon, because the earlier universe is opaque as the interior of the sun. What happened 380,000 years ago will be forever obscured. put it in a straightforward sentence. And the cosmic microwave background is one of the earliest brick walls. He defined the limits of observation. On the surface, the wall is still receding. After a second, point one has been gone 131.80 billion years, 0.1 more second of light reaching us. And so, the radius of the observable universe, there's an extra light second per second. That's about 300,000 kilometers of new space. Into viewed up by day that we see about 16 billion more every day. Universe in. But when you think about it, you will think of another layer. Although the screen is getting bigger, the sources of light are being carried away by expansion. For example, a galaxy that emitted photons 13 billion years ago, now likely to have been dragged 30 billion light years away, that we see him as he was back then, rather than where he is now. This video is zooming in. The actor's sense of dislocation in retreat that it's actually the everyday world off cosmological observation. Even so, microwave background, they still tell us a crucial fact. The universe was smooth to near perfection. Temperature fluctuations are only a few parts per million. And it's these little ripples that eventually gave birth to the galaxies we have today. Now, look beyond what the bubble might look like. According to our measurements of the microwave background, the universe is nearly uniform on the largest scales. In other words, that no matter where you start, the ingredients and proportions are similar. It's actually like a perfectly evenly mixed cake batter. Each spoonful contains the same ingredients. Push down from here. If our piece of the observable universe, about 20,000 galaxy, that means out of the world. In another area of the same size, there is a high probability that there is a similar 20,000 a galaxy. The same holds true even further afield, and this pattern will continue piece by piece. And here's the exciting part: if space is close to wireless in scale, and keep it even, that means in any given machine, all possible arrangements of matter will repeat itself somewhere. That sounds like metaphysics, but the answer is mathematical. Limited microscopic arrangement, plus the volume of wireless. Repetition becomes inevitable. And so, far in the previous paragraph, the metaphor of the unity of paper and picture, hooked up with the observational evidence here that we don't have to go out and find a place for the universe. What really needs to be tracked, and that's how the sheet continues to grow. And as he approaches infinity, how to fill all possibilities, because this one-dot paper makes everything possible on an infinite scale. Sex is written all over. The harshest conclusion comes. Repetition is inevitable, and so, you might as well hit the bottom with a deck of playing cards that if you can shuffle the cards indefinitely, the exact same sort will appear again sooner or later. The universe works in a similar way that it's actually just replaced by atoms and their arrangement. And so, in an extremely distant place, must exist another you who is reading this text. This is not a metaphor, but it's actually a literal inference, because in those lights can never reach our area. Quantum mechanics has turned matter line up in every possible way. These include the one that is exactly the same as your current state. And so, some of you will stop reading at this moment. And so, many of you were never born. You are living in the history of the Earth. In a completely different version. It even gives us a sense of scale. These copies are approximately behind one. Follow 115 zeros away. This number is so large that if you write it down in its entirety, just the length of the string of numbers would exceed the size of the entire observable universe. But as long as space is truly infinite, that distance is limited, and so, somewhere, another fact that you just realized. A little bit further. Another one you just realized this fact before, but above. It all rests on a premise, out of the world, that it's actually about the same as ours. What if he doesn't look alike? Observations in recent years suggest our part of the universe may be a little thin, like a galaxy density. Below average cosmic voids. If so, that means cross the observable boundary. You might see a more crowded space, more galaxies, more black holes, more strenuous activity. Maybe the opposite. It was an almost empty liftoff. A bolder theory. He also pushed his eyes back to the original moment. A brief but frantic cosmic explosion may tear the whole into many properties. Jung pocket universe. They may have different physical constants, different particle spectra, even obey completely unfamiliar laws of physics. Let our textbooks expire as soon as they leave the country. And here we are, the reason why everything seems normal. just because we happen to live in this place. In the pocket recipe. But there's a deeper subpoint, requires a positive response. What if the universe wasn't wireless at all? An expanding wireless universe. Bring a seemingly beautiful back theory. How? Do you make wireless bigger? Now, mathematics says it cannot be infinite. Plus, any finite number is still infinite. Multiplying by 2 is still infinite. You can't, into something that already contains everything. What to add? Observations clearly tell us. Space stretches everywhere. To break this hook, the key is to expand. It's actually the intuition of becoming more infinite. Remove that it's actually better to say that the scaling factor is getting bigger. Imagine an infinitely large sheet of graph paper. Each grid is wide and wide. Now pull it as a whole every 2 inches. Paper is still infinite, that we're still running out of squares, but the distance between any 2 points doubles. The nature of cosmic expansion. Exactly that it's actually not about adding wireless to wireless. It's actually about scaling up the unit size of the branch. Let all distances increase proportionally. And so, a galaxy now 100 million light years apart. When the universe was half the size it is now, that's 50 million light years away. And the inference goes on that if the universe were infinite at this moment. And so, at the moment of the Big Bang, that he must also be infinite. The Big Bang is no longer like taking matter from a point, fireworks blasting towards the outside, that it's actually more like infinite space. Start expanding at the same time in each position. And full of energy. In other words, Big Bang happens everywhere in infinite space. He has no centered, no borders. There is no external location. Can claim to be the center, because no matter where you look, that it's actually all the same. This perspective, on one hand, explain why we are moving in all directions. Almost identical universes. Also explained, why can't we find the edge or center? On the other hand, he also threw out new questions that if the universe contains infinite matter and energy, why don't we get infinite density? The answer lies in the definition. Density is the total amount. Pay attention to the volume. Even though the numerator, denominator both tend to be infinite, as long as they grow at the same level, straight can still be limited. And so, the universe could be wireless, placing wireless substances, while maintaining a limited average density, quantity, and approximately a few grains per cubic meter. Starting from here, it becomes private in a truly infinite universe. Any event that satisfies the laws of physics will happen infinitely. Repetition is not just another you. It's actually about every version of every story. Tragedy and triumph, beauty and cruelty will play out somewhere. If that's a little unsettling, might as well. The possibility of turning the camera back to the finite universe, that a universe with a lens. We'll press the next question: what is beyond the boundaries? Can space really have an end? If you try to go through this lens, what will happen? These questions, many scientists are more inclined to models with maximal or nearly infinite space. It's actually hard to imagine conceptually, but at least what lies beyond the borders. This question is recounted. With the latest cosmic microwave background measurements, we're either going to have a wireless universe or face one that it's actually too big to see anywhere. Approximately flat universe. The most convenient explanation that it's actually an infinite expansion of space in all directions. And so what we see today got bigger and no longer like a house. The room is as fast as adding space. It's actually more like putting. Already existing unrestricted part overall pull loose. That's what's pushing this branch to keep stretching. What mechanics is it? To put it bluntly, the universe is evolving in a way. Make all factories on Earth extremely fast, starting from a near-empty quantum vacuum. New production space, a rough calculation. Every second, the observable universe would be about 11 times larger. This is followed by a cubic meter of 78 zeros. It's actually so big that even if you count one every second, it takes far longer than the age of the universe. Replay this time by yourself billions of times. Still not enough. But a quantum vacuum is not empty, that it's actually a pot of foam that never stops. Whisker particle. They appear and drown in a very short period of time. That's quantum mastery. It brings energy to every point of the space. What really subverts intuition is, this vacuum energy will be expressed through attractive forces. Unlike material attractive forces that pull things together, Vacuum energy repulses. It pushes space out. More space, the more vacuum energy there is. The more energy a vacuum has, the faster it expands. The faster it expands, the more new space there is. Open this circuit to the maximum. You get an uncontrolled spike. In the very first moment, the process goes crazy. The expansion rate of space. Faster than light can travel through space. It's actually not about anything going faster than light. The treadmill is accelerating. You can't run on a treadmill like that. During that time, a region smaller than a proton can be praised at unimaginably short intervals, close to the size of a basketball. That sounds like science fiction, but the ledger of quantum mechanics requires it to happen. As long as you can return it in a short enough time, you can borrow energy from the vacuum. The billing stage. The universe has borrowed huge amounts of energy from a vacuum to open a factory production space, and then it's paid off with the inflation itself. It's actually like taking out a loan to buy a money printing machine. That means use the printed money to pay off the loan. Here's the thing, it's actually working so well. All he had to do was create enough space to solve some cosmological problems. But he didn't stop work right away. It was over completion, produced far more territory than needed. And so, our entire observable universe, it's actually just this giant explosion. A small patch in the fabric. Imagine blowing a balloon up to the size of the Earth. And what we can see so far, it's actually about the size of the tip of a needle. What's even more interesting is, although the early explosions have stopped, the expansion continues today. It's actually just that the rhythm has been changed to another character. It's actually about 68% of the universe by energy, the way it behaves. Almost identical to vacuum energy. Fill the space evenly and provide attractive force. Let the expansion accelerate. As the volume increases, new energy is constantly emerging to fill new spaces. It sounds like it's creating energy out of thin air. It's actually kind of fighting conservation of energy. The key to resolution is in the ledger of attractive forces. Attractive force is negative. When the space is opened, the attractive force between substances decreases. This more negative energy can counteract the symptoms of new dark energy. The result is that new space is constantly being created on one side of the universe, while balancing the general ledger around zero. According to this script, the expansion will continue for an extremely long time, far beyond human imagination. Every moment, a new space is born. New dark energy emerges. The stretching of the universe continues to accelerate, the reason why the universe grows. Not to occupy some external place, it's actually the expansion itself. They're creating their own stage. But even so grand, all of this still requires evidence to do things. Where should we find him? The clues are not in distant myths, and it's hidden in a very simple place. When you put an old-fashioned, when the TV switches back and forth between channels to in the murmur of those snowflakes, about a tiny fraction of the light is coming from the very earliest in the universe. The answer lies in that snowflake. 1964 at Bell Labs. Penzias and Wilson, straight. Get rid of that old man sound in the antenna. And so, they switched directions, school equipment, even cleaned the bird droppings from the antenna, but the noise still doesn't go away. And it turns out it wasn't a malfunction. It's actually the echo of creation. They hit it by mistake. Received cosmic microwave background radiation, the afterglow of the Big Bang. Because space keeps expanding, this ancient light is stretched all the way, cooled. Today it is only about 2.7 K above absolute zero. Because of this discovery won both men the Nobel Prize. It also gave the universe an expansion, the most direct evidence. And here's the thing, this background light doesn't just exist. He also has inflated fingerprints on the spectrum. Initial visible light around 3000 degrees Celsius. And as space gets stretched, it goes into the infrared first, switch to microwave, and then finally radio. At the same time, the entire sky is almost as bright as a mirror. Even to a few parts per 100,000, this matches the prophecy of the explosion. Without a quick stretch early on, smooth out the irregularities that we should now be seeing huge temperature differences. But that's not the case. And so, the problem progresses. Where do those remaining tiny fluctuations come from? The answer lies at the quantum level. Inflation converts quantum fluctuations at subunit scale, pulled to the cosmic scale. These faint energy fluctuations, and it became the seed of galaxies and stars. In other words, you can read about it here because of quantum uncertainty, magnified by the universe into the macroscopic world. And then the evidence turned into graphs. With the Cosmic Background Explorer and the Planck satellite, humans put this map of temperature fluctuations that it's actually very detailed. Results the distribution of a kernel diagonal scale, and the theoretical curve of the explosion fits almost point to point. Based on this ancient microwave that we can not only see, it can also illuminate the universe. Geometrically, space is nearly flat within measurement accuracy. Componentially, ordinary substances make up only about 5% of the total. Dynamically, the rate of expansion and the age of the universe can be inverted to a very narrow range. And here's the intuitive part, it also gives us an amazing sense of scale. The entire observable universe today, once compressed into a volume about the size of a beach ball. The compression here is not about stuffing things into boxes. Instead, space itself is compressed. That beach ball wasn't a container for the early universe. It was the universe itself outside surroundings. Only the compressed space-time it expands and cools. Only then did we have the starry sky. That means hold this space and time. Where does the energy come from? To find out, scientists, move your gaze to a more stable celestial phenomenon. In 1998, two teams used a type supernova as standard candle to measure the attractive force. How should inflation be slowed down? The idea is simple. The actual brightness of these supernovae, compared to the standard brightness, coupled with a red instrument, you can figure out how far they are. In one picture above, the conclusion is completely reversed. Distant supernovae are fainter than expected. That is, farther than the standard model. In other words, the space where light meets on the road pulled more than we thought. And so, not only was the universe not stopped, it's actually accelerating. It also won the Nobel Prize at the same time. It also introduced us to a new character, and that character is the dark energy. He now makes up about 68% of the total mass energy of the universe. That's more than all the ordinary stuff combined. More powerful than dark matter. It's actually weird in that it's neither agglomerated nor diluted. Substances become thinner as they become larger. It can be basically unchanged when expanding according to the density of energy. And so, the universe gets bigger, the greater his overall influence. Early matter and radiation have the final say. Dark energy is just the background, waiting for the material to be pulled more and more thin. The repulsive effects of dark energy are starting to rise, became dominant about 5 billion years ago. After that, the universe entered an age-off acceleration all the way, pushed down on this trend. More and more distant galaxies will move away from us faster than light can catch up, eventually bring up the observable range forever. But what is this invisible pusher? The leading candidate is vacuum energy, the quantum factory, floating in a seemingly empty base. Naive estimation of illuminated subfactory theory that a vacuum should be filled with tremendous energy can be compared with observations that by a factor of 10 to the 120th power. That's pretty much the worst prediction in the history of physics. And so, or we're missing the key puzzle piece of the quantum world. Either nature has some kind of mechanism, cancels almost all the vacuum energy, just a tiny bit left to push the acceleration. In addition to that, it was also suggested that dark energy may be a kind of heart that pervades the universe. And so, people simply suggested rewriting the law of gravity on a cosmic scale in no matter which way. The current situation all points to the same conclusion, our ignorance of him. Much like when ancient humans looked up a thunder, lightning. But he did go on to shape the fate of the universe. Speaking of the fate of the universe, together, we'll go to have to zoom back to earlier time. Many people asked if it expands faster than light, what will happen? The answer does not contradict the principle that no object can travel faster than light, because it's not objects that run fast, that it's actually the scale of space itself. Just a tiny moment after the Big Bang, the universe entered the so-called blaster. The distance between any 2 points, double and double in an incredibly short amount of time. And so, fast that light can't catch up, straight point of view 0.2 ants, standing on a rapidly inflating balloon that no matter how they climb, will only get farther and farther away. By order of magnitude, inflation increases the size of the universe by at least 1, followed by 26 zeros, and all this it only occurs in about 1 second in 110 million/10,000 hours. Make a comparison. Just walking 30 centimeters in a Namyao, driving this crazy stretch it's actually a quantum field called an inflationary magnetic field. Unlike many plants that have zero carbon deposition energy it's actually trapped in a high-energy false vacuum, like a pool of elevated water, can in a short time, constant delivery of energy to the space. The fear of exponential growth is that in the early stage, there is no mountain and no dew. Later, it sprinted suddenly that he not only smoothed out the early ups and downs, make the sky look almost the same. It also pulls the regionality of the universe to near flat, and amplify that tiny quantum grasp, became the seed for all future structures. Your galaxy, your star, even the atoms in your body can be traced back to the random ups, downs of that moment. But then a more disturbing issue arises. If the explosion had happened, why can it only happen once? The kind of magnetic field that drove the initial explosion, most likely still lurking behind the scenes to this day, as long as the conditions are right, will trigger a new round of exponential stretching. He could be at any time. Launch a new explosion anywhere. Bubbles will form there, and it expands outward at nearly the speed of light. Everything along the way will bear written. Inside the bubble will operate according to a whole new set of physical laws. Our atoms will be broken down. The rules that we're used to are suddenly broken, and the worst thing is that we will not receive any warning. But for the explosion theory, and that's not the most astonishing conclusion, more likely, our universe, just a bubble in a sea of infinite bubbles. You are reading these words at the moment. There may be countless universes being born elsewhere, and they all carry different natural narratives, different particle families, even different physics grammars. It sounds like science fiction, but he's an extrapolation of the explosion theory, as long as it happened to him once. Quantum mastery. It will allow him to repeat it on a bigger stage, and so, bubble universe after bubble universe is blown out. Each expands and then cools. It might even give rise to its own galaxies and stars. Our universe is just one of them. In another bubble. Gravity may be stronger. As soon as the star lights up, it collapses into a black hole. Gravity may be weaker matter. And so, bubbles have no electromagnetic force, and no chemical reaction can take place at all. And so, bubbles will stay in the inflated state, never cooled enough to form atoms. The vast majority of bubble pore are uninhabitable, but in a truly infinite sea of bubbles, even the most unlikely combination. It will also appear in some corner. And so, the human principle has a new explanation. The reason why we are in a place. It looks like a very finely tuned universe. It's actually not that the universe is tailor-made for us, but because there is only such a universe that to breed observers. In other words, that we can see him, because he allows us to exist. Now, the problem is not just physics, and then philosophy. If there are infinitely many universes, that means all possible experiences. It's actually going to happen somewhere. The choice you didn't make will be done by you in another bubble. The tragedy you avoided will fall on another version of you. Your unfulfilled dream will also bloom in another branch of reality. In this way, uniqueness can be diluted to the point of being almost meaningless. Select weight will also be divided into countless parallel scripts. The trickier part is testability. By definition, the other bubbles are outside our world. They will not send light. No attractive force that we can't directly prove their existence, that we can't measure their properties. Because of this, many scientists have reservations about the multiverse. Unverifiable, but it's actually not strictly science. But on the other hand, mathematical derivation of explosion, strongly pointing the path to eternal explosion and bubble relay. The same set of successful explanations. The equation for the expansion of the early universe also quit naturally. It continues to expand in a larger space. The conclusion of continuous bubble formation goes with this. In the cosmic microwave background, the subtle statistical patterns are highly consistent with the explosion predictions, although this cannot be directly proved, the existence of other bubbles. But let us. Perhaps you are living in a society that supports multiple. The best evidence of the universe. More confident. Go here. You might think you're just imagining bubbles in 3 dimensions, but the latest physical attempt reminds us the truth may be even stranger if it expands. Is happening in a direction we can't perceive. Explicit theory requires that space has 9 dimensions, except for the 3 dimensions we are familiar with. There are also 6 extremely curled tiny dimensions, hidden here and now. It's actually just that it's hard to detect even particles that we are likely to be like ants walking on a garden hose, only move back and forth along the pipe. And so, I mistakenly believe that the world has only one end. If these extra dimensions really exist, they may expand with 3D space. In this way, the question of where the universe is expanding. There is another answer. Our 3-dimensional space may be a membrane, positive extension into higher dimensional hyperspace, the accelerated expansion we observe. Maybe this is the film, deformed in larger dimensions. The more daring grinding world model even proposes. All particles and forces except attractive forces are trapped in this 3-dimensional membrane. Only attractive forces spill over into the extra dimensions. This also explains why he appears particularly weak, that if there are demons parallel to us in high places, they may be in directions we can't see, close at hand, even occasionally collide. And so, me models simply incorporate what we call the Big Bang, explained as a collision event between magic and magic. The cosmic microwave background may have been the impact, the afterglow left behind. According to this assumption, on very long time scales, the membranes may also meet repeatedly. It's actually like hitting the restart button every time that in our 3-dimensional space start a new cosmic evolution. There are even more outlandish speculations. When our familiar 3-dimensional space seems static, the extra dimensions themselves may be expanding. Or some dimensions are getting bigger, others are shrinking. And so, the overall volume doesn't necessarily change. The 3D slice that we're on seems to be getting wider. Now, this is all hypothetical, because we can't touch the extra dimensions directly. The Large Wall Collider is searching for particles, signs that seem to disappear into hyperspace. But so no hard evidence has been photographed yet. This might mean that the extra dimensions didn't exist. It could also mean that they're even tighter than we thought. Even so, the mathematics of apparent theory still implies extra dimension that it's actually probably impossible to describe reality. The missing piece of the puzzle. Take a step back. Even without those hidden directions, the shape of 3-dimensional space itself is enough to rewrite the meaning of where the expansion goes. General relativity allows for 3 geometric forms that it's actually as flat as a wireless plane. Positive area ratio like a sphere and a satellite secondary rate. Observations show that our universe is either flat. Or it's too close to flat to measure. But flat is not infinite. A piece of paper is flat, but you can roll it up like a cylinder. Or glue the edges together to make a donut, partly still flat. The whole can be closed and limited. If space really closes itself in some way, and so inflated, you just increase the size of the closed structure. He didn't enter some external warehouse, that it's actually growing into a bigger version of yourself. Go down the line of closed geometry. He even leaves observable traces in a donut-shaped universe. Light can circle the field. Go back to square one, and we have, maybe in different directions, see a doppelganger of the same distant galaxy. In the cosmic microwave background. Light should also appear multiple times, the repeating pattern superimposed after wrapping. Astronomer tried to be on the map of the universe, looking for signs of closed space, but never found any decent evidence. This could mean 2 things. Or the universe is much larger than our observable range. Or at least for now. On a detectable scale, it doesn't have this self-closing structure. In other words, the universe may indeed be like a duff nut, just this donut. The big light hasn't had time to circle idiot. If we take the perspective one step further from space, you will see that space and time are actually 1.4-dimensional space-time, and so the shape is complicated. Inflation doesn't just pull space apart. It also alters the relationship between space and time. In the early universe, everything is extremely compressed. The passage of time is completely different from today. And at the same time, this concept, loses its unity at great distances. As the space is stretched, time can be stretched. Therefore, a seemingly counterintuitive sight emerges. The speed at which some distant galaxies are receding seems to exceed the speed of light, but they're not running in space, that it's actually space itself that takes them further away. At the same time, lengthen the time scale together. For those galaxies, they're almost static, just a ruler and a clock between us and them. Changes along the way. The theory of relativity tells us that, starting from anywhere in the universe, the inflated picture is all the same. Every observer feels at the center. Everything else is gone. N01 has a preferred frame of reference. There is no real foreign aid. And here's the thing. This stretching is not an abstract concept. It can be directly measured, for example, in a nearby galaxy. A supernova goes from variable to dim, maybe only 3 weeks. But if the same supernova explodes, happens faster in a regression. In farther galaxies, this process in our eyes it will be like it's actually elongated in slow motion. The reason is simple. Light that transmits event information got stretched during the trip. Not only are the wavelengths elongated, the time interval between the light pulses also extended. And so, what we see is a version where time is slowed down. Use an intuitive number to scale. Light from galaxies in the observable fringe region, redcoat factor, about facts. In other words, that their events occur to us, will be a full 10 times slower than the local process. This also explains why is the age of the universe. The truth is, with a stance. Starting from our perspective, it's actually about 13.80 billion years old. But if you were standing on one of those distant galaxies, look back at us. This space will look much younger. In other words, the early universe was not only more compact in space. Time is also more compact. Many. Evolution that would take billions of years to complete today. That time could happen on a shorter quick scale. The first stars, the first galaxies, the first black holes were all born in that rhythm. Go one step further. Expansion. It also shattered our inherent intuition about the same time. You think two things are happening at the same time. A distant observer may be out of sync. There is no unified present in the universe, only assassins in their respective regions. And as the influence of dark energy gets stronger, and this time-lapse effect is magnified, future observers look into the distance that you'll see more extreme time lags, until those events were almost frozen. This brings us to the script of the future of the universe. According to the current understanding, inflation makes matter and energy thinner and thinner. After a very long time, the universe is headed for a hot season. The temperature difference is smoothed out. The workable processes are completely exhausted. The whole world, just a uniform void near absolute zero. The roughly correct timeline is like this. About 100 billion years later, the last stars ran out of fuel and new stars will be born. The universe enters the age of alkalosis, dominated by icy stellar remnants. And then about 10 to the power of 34 years later, protons can decay. The building blocks of atoms, planets will disintegrate on their own. Cosmic finger electron, positron, and photon, floating in the ever-expanding void, push the scale even further. About 10 to the 100 years later, black holes will be the only significant source of energy. They will evaporate slowly through Hawking radiation. The lifespan of supermassive black holes, even 10 to the 100 years, when the last black hole transform into faint radiation dissipation. The universe will reach a maximum state. If there's no temperature difference in a chemical reaction, computing cannot continue. Life has nowhere to go, unless by the nature of energy. And so, meeting fundamental is going to happen in the future. Otherwise, accelerating expansion will take the world all the way, push towards this cold end. And in the near future, and it's not gentle. As time and space are pulled apart faster and faster, distant galaxy will fall out of our observable range. They will not be destroyed. It's actually retreating too fast, and so that their light will last forever, far from reaching us. And then the cosmic microwave background radiation will also be pulled to undetectable bands. The astronomers of that time, only a lonely local group of galaxies will be seen. There's a void all around. The key evidence of the Big Bang is long gone. In comparison, the ultimate ending of the universe being torn apart will only appear on more extreme cameras. If you increase the intensity of the energy, it accelerates, will crush all known forces, starting from gravity, the electromagnetic force that holds the nucleus of an atom together. Let it all go. The universe will be disintegrated from within. But no matter what the ending is, one thing is certain. The so-called empty space is not empty at all. Vacuum is a quantum melting pot that on the tiniest of scales that it's actually boiling. It's holding chestnuts, and it appears in an instant. Drowned in an instant that it's actually so fast we can't catch it at all. But it leaves real physical traces everywhere. Imagine that. You take a resolution that a microscope much higher than the nucleus. Emptiness as you zoom all the way down to Planck scale. Approximately minus 35 meters. Asterisk originally smooth spacetime objects that it will roll like boiling noodle soup. Geometry is constantly changing between life. The accumulator borrows energy from the vacuum, and the uncertainty principle says, the more they borrow, the sooner you have to pay it back. Electrons and positrons come in pairs. Pair drowning. The entire process may only take 10 to the power of 21 seconds. More massive virtual particles. Survival time will be shorter. All kinds of accumulators allowed by quantum field theory will be here, take turns in a seemingly empty vacuum. And it is this invisible quantum furnace determines the expansion of the universe, how to open the cloth of time and space step by step. They're not metaphysics that it can leave fingerprints in the lab. A classic example of this is the Casimir effect. When two metal plates are exhausted in a vacuum, the boardroom can only accommodate an accumulator with a wavelength shorter than the gap. Long wavelength can't get in. There are still long wavelength accumulators outside the plate. This asymmetry inside and outside creates a pressure. Push the metal plates together. This force can be directly measured, equivalent to. You really feel the pressure of a quantum vacuum. Let quantum bubbles in cosmology really out of the loop. They should be true. The energy density of emptiness contributes. When physicists do the math, it was outrageous, according to the theory. The universe should be growing at a much faster rate than observed. Compare. Theoretical value ratio according to the true intensity of energy, 0.120 defenses to be larger than 10. This is the history of theoretical physics. One of the most embarrassing misses. Or our understanding of the quantum world that a crucial piece is missing. Either the universe has some kind of mechanism, cancels most of the vacuum energy. If we can solve this vacuum disaster, maybe we can uncover the true face of dark energy. Maybe that small handful of unacceptances. It's actually the dark energy that drives this accelerated expansion. Maybe the universe will suppress most quantum bubbles. Only a very small amount is released. Or else, our computation is never right. But here's something even bolder. The vacuum may be filled with hidden fields or extra dimensions, leaks the vacuum energy out. Even the concept of emptiness itself, that it's actually just an illusion from our limited perspective. Loop quantum attractive force. Space is organized by an infinite number of discrete rings. Network string theory. Treat it as high as medium string. The result of interaction that no matter which side you take, the conclusion is approaching the same direction. Space is not the background of nothingness. It's actually a structured ring. The expansion may be stretching this ring, rather than creating more space out of thin air. But even with our understanding of a vacuum, very limited, and the paths that he took to the future are still amazing. If the acceleration is really getting stronger and stronger, what will happen? There is an extreme scenario called the Big Rip. About 22 billion years later, dark energy will be so strong, gradually break down all the binding forces of nature. The universe is not that it gets cold over trillions of years, that it collapses very quickly, very quickly. The rough countdown goes like this. About 1 billion years before the Great Rip, galaxy clusters are disintegrated. About 200 million years before the end, galaxies like the Milky Way would be torn apart. The star is dragged out of its attractive force. According to the finish line, 30 minutes. The collapse of the planetary system's attractive forces. The Earth will be thrown away from the Sun. The Moon will also escape from the Earth. The last few minutes. Molecular bonds are broken. Gas dispersion. The oceans are no longer boiling because of the reheating up. It's actually that the distance between the molecules is increased, that I can't stand the force. About 10 to the power, 12 seconds before the end. Atoms and disintegration. Strong interaction completely disarmed. Last minute. Connection distance and time interval. This metric used to describe the world could be meaningless. Of course all this that it all depends on whether dark energy continues to increase. If he remains constant, big rips don't happen. The universe inhibits acceleration, but slowly towards the hot pole. Existing data support is essentially constant that it's actually just not accurate enough. Future more detailed worry observations. We'll continue to ask him if he is changing that if true confirmation enhances. The specific countdown can be calculated in 1917. Einstein had just written his general theory of relativity. I ran into a problem. His equations naturally predict that the universe is either expanding, either contracting, does not support a static and unchanging universe at all, but the prevailing wisdom at the time that we believe that the universe is static and eternal. To match this observation impression, he added a new term to the equation, lambda cosmological constant. Think of it as a little bit of energy that comes with a vacuum, like a gentle repulsive force. Just counteract the attractive force that it keeps the universe in place. This patch looks reasonable that it's actually been working for about 10 years, until Hubble used the large telescope at Mount Wilson, distant galaxies, measure the distance and speed one by one. I found that they generally stay away, and the further away, the faster the retreat. The universe is not static, that it's actually expanding. This is just before Einstein mega grew the tree. Original allegory of the equation, and so he decisively threw away the cosmic tree. I laughed at myself. It was the biggest mistake of my life. Ironically, decades later, supernova observations in 1998 invited this cosmic tree back again, because we found that expansion is not uniform, that it's actually accelerating. To drive this acceleration, you need a uniform, fill the space in energy density that produces an attractive force. It works exactly like the cosmological constant. In other words, if energy is the cosmological constant. And so, Einstein's intuition back then it was incredibly prescient. The reason is wrong. Direction is right. Take a closer look. The value of vacuum energy is very small, but not zero. About 1 by 10 to the power of 10 joules per cubic centimeter. If that's a seemingly insignificant number, could once carry the volume of the entire observable universe. It surpasses all matter, and the total energy of radiation directly dominated the late evolution of the universe. The challenge is that quantum field theory calculates the energy of a vacuum. The result is 120 times larger than the observed value. This is the famous vacuum disaster, or our understanding of the quantum world. Key puzzle pieces still missing. Either nature has a mechanism, cancels almost all the vacuum energy, leaving only a tiny balance. It was also suggested that dark energy is not a constant, that it's actually a field that changes slowly over time. Use this dynamic dark energy to bypass disasters. In terms of current astronomical data, the simplest cosmological constant model, still the most appropriate explanation, cut back to Haber's view of the sky that night. The scientific community was still debating vortex, the vortex nebula part of the Milky Way. Hubble uses the benefit of variable stars as a yardstick. The distance between these hazy celestial bodies, directly measured to millions of light years and beyond, make it clear that they are separate galaxies. That means he took the distance of these galaxies, the light. Puhangi draws on a picture as a result. You can see a pattern at a glance. The farther away the galaxy is, the faster you retreat. That's Hubble's law today. At first he thought galaxies are in space, scattered like fragments of an explosion, but that would put the Earth in the center. Apparently the Gobani principle. A more accurate explanation would be that space itself is expanding. Think of galaxies as dots on the surface of a balloon. Once the balloon is inflated, each point will see the other point go away. And the further away you are, the faster you retreat. There is no point center. Hubble's law. Therefore, it became the first evidence of the expansion of the universe. And his proportional constant is Hubble's constant. Describe how fast the regression is per unit distance. Haber's distance calibration confuses deformation types. The initial value was too large. The estimated age of the universe is only 2 billion years. Even younger than the Earth. The caliber was later corrected, returned to a reasonable age range. And the further away, the faster it retreats, the more linear it's always going to be, starting from nearby galaxies to the farthest visible galaxies. All follow the same curve. This curve not only does astronomy, starting from the two-dimensional sky mapped to the era of punctuation, entered the era of being able to measure the universe in 3 dimensions, and they brought a key issue to the fore. Will the expansion continue forever? Well, it depends on how much stuff there is in the universe. Physically, there's a critical density line. Determine whether the universe will grow forever. Or will it eventually come back to explore? Intuitively speaking, inflation takes everything out. Attractive force pulls everything back. The competition is the mass of matter per unit volume. Exceeding the critical value, attractive forces will eventually win. Inflation will slow down, stop reversing towards big carbon. Shrink below a critical value. Inflation always prevails. The world will be diluted to near emptiness, towards a calorimeter, exactly equal to the critical value. The expansion rate will get closer and closer to zero, but never reach zero. It's actually like throwing a little ball just right. It will continue to fly to infinity at the same time. The speed slowly approaches zero. What makes your scalp even more numb is the blade of the universe. It's actually almost like a vacuum. Converted down, there are only 5 Kingiwonka reactors per cubic meter. But it was him determines all galaxies, stars, planets, and even our final destination. For decades, measuring the true density of the universe, it's actually been considered the holy grail of cosmology. It sounds simple. Add up the masses of all the substances. Just divide by the volume. But when it lands, it's bad, because most of the material in the universe is invisible at all. The rotation curve of the galaxy has long been leaked. Peripheral stars are spinning too fast to keep them from being thrown away. Required attractive force, that's about 5 times the mass of a visible star. Therefore, they have a name for this invisible quality. Dark matter. It doesn't emit light, does not absorb or reflect light. That be why attractive forces only that we can only rely on it against the stars. The role of gas and galaxy clusters. Indirectly identify its existence. Let's add in the dark matter. The total density of the universe. Only about 30% of the part density. According to this account, the universe will keep expanding, finally, slowly approach the calorimeter. But the appearance of energy rewrites the whole conclusion. Dark energy not only makes the total energy density too high, more importantly, he carries negative pressure. In Einstein's equation. This component will push the accelerated expansion of space-time. In other words, no matter how much ordinary matter there is, as long as dark energy is present, the expansion will go faster and faster, combining existing observations. Our universe is about 27% dark matter, 0.68% dark energy, and 5% ordinary matter. Considering the negative tooth effect off dark energy, this recipe let the universe fall almost exactly near the critical density, if between different geometric destinies, found a delicate balance, which brings up the issue of flatness. Why is the density so close to the critical mass? In most evolutionary models, density should have veered off critical very quickly. Either it's too big for him to shrink, or too small to fly away. To maintain just right. The initial conditions must be accurate to countless decimal places. The cosmic explosion offers a way out. During that period of exponential and stretching, any initial area ratio will be smoothed out. At the end of the explosion, the universe naturally approaches critical density. But then a coincidence problem arose. Why do we live in a material world? A brief window on a par with dark energy. Maybe it's just observer selection. Skills are formed only in the structure. It's actually not diluted out. Observers like us have a chance to look up at the sky and ask questions and zoom in again. The hypothesis of a single universe may not hold up. In the path of the eternal explosion, our observable universe, it's actually just a small piece of a much larger inflated region. Quantum fluctuation triggers new bubbles elsewhere from tomato time. Universe expansion, cooling out galaxies and planets. And so, bubbly amines have more energy, they run faster. And so, bubbles are denser. Evolution is slower. Others have already returned to the Dayton shuttle, even heading towards the wanton martyrs, and bring in the many worlds of quantum mechanics. Almost every microscopic fork will generate a parallel version of history. And so, there's no cap on the number of parallel universes. Every moment a new branch is born. In some branches you go to the diary. In other branches, you witnessed him saying that there are more points. Cheery, you continue to live in the context of accelerating expansion. Evidence is hard to find because these universes are causally isolated from each other. Scientists have also tried looking in the cosmic microwave background, fingerprint of bubble collision. And so far, nothing's been said. Even so, the idea of a multiverse still changed the way we talk about inflation. For our space, inflation is overall growth. For larger structures, it may just be a more complex manifestation. Back to information wings. It becomes more personal. Every thought in your head, every memory that it's actually basically an arrangement of matter and energy. The expansion of the universe, slowly arranging these to the west, it looks like information destruction. But physics also says that information can't really be destroyed. The holographic principle provides an angle. All the information in one volume can be encoded on the boundary surrounding him. As the universe expands, the surface area of the boundary also increases. The storage bit increases. Complexity still has room to expand. Quantum entanglement is messing with this that he let cross. The example of great distances remains relevant, seems to remind us. Information is more about relationships, rather than absolutely unknown. Here's the thing. The causal link will be severed by accelerating expansion. It's actually primordial communication. Will eventually move away from each other faster than the speed of light. Information, locked in isolated cosmic bubbles that do not communicate with each other. Macroscopically, the history of the universe is still structured at large scales. Leaving lines in the microwave background, microscopic, local information will be searched for treasure, cannot be recovered. Finally, the camera is pushed to the limits of the future as dark energy continues to pull space-time apart. The cosmic microwave background will be blocked by a red beam. Distant galaxies will fall from the edge off the world one by one. The news names at that time were looking up at the sky. Maybe you see a few nearby galaxies, you don't get expansion. You can't see the afterglow of the Big Bang. They will come up with a seemingly simple, completely wrong conclusion. The universe is static and eternal. The time is broadcast to about 150 billion years later. Dark energy will destroy most galaxies, push out of the world. Their light is drawn to the longest wavelength of the observable universe. The result is to completely disappear from observation in the eyes of that era. Only our local group of galaxies remains visible at the same time. The Milky Way and Andromeda, along with satellite galaxies, will merge into an isolated giant elliptical galaxy, floating quietly in the empty void for them. And that single burst of starlight is the entire universe at the same time. The cosmic microwave background also goes out. Because space continues to stretch, the wavelength of this round radiation will be pulled too. The observable universe is longer, and so it can't be detected by any instrument. And so, all the evidence that the universe had a beginning will be lost. Even the red instrument of the expansion mystery, the distance relationship, does not light up. You can't see distant galaxies. You can't discover Hubble's law that can't prove it directly. Space is stretched again. Therefore, the universe they see would appear completely static based on this adaptation. Future scientists at IT may well establish another set-off cosmology. Identify the only giant galaxy exists in infinity from beginning to end. The static void. They can't even imagine. The universe was once less than billion soft galaxies, and they're swelling away from each other. In other words, they will live in a place. A universe deprived of its own history. Go one step further. This loss of perspective will only deepen. Future observer also lost key clues about early oxidation. The nuclear reactions that shaped the original elements ended billions of years ago. Its traces remains in the chemical composition of the oldest stars, and it's getting harder to recognize. The result is an epistemological crisis. Wisdom and technology are still powerful. Universe IT gives few hints about its own nature. The method is still the same method, but there is too little available evidence. The conclusion will be biased. Therefore, we have to reflect. Our cosmic knowledge today, will it also be limited by the times? Have you missed it? Only early observers can see it. Key information that has now been bloated. Perhaps a civilization born just after the Big Bang that I've seen things we'll never see again. And the same analogy extends to future endpoints as the space continues to expand. The processes that support life will eventually become unsustainable because the gas becomes too thin. Gravity can no longer pull them together into clouds. Star formation would come to a complete halt. Existing stars will run out of fuel and gradually press down. Black holes will slowly evaporate through Hawking radiation that finally in the vastness of space. There are only rarefied elementary particles. The universe is approaching a perfect diary. If there were still observers, the world they face will be more deceptive. There are no stars galaxies it has no structure I see sparse particles floating in infinite space. And so, it's natural to think, the universe has always been so monotonous that I can't imagine how prosperous it used to be, starting from abundance to emptiness. This is putting the question of where the universe is expanding, pushed to the extreme. This question presupposes a plausible, but superfluous premise. Inflation must have a purpose. There is an end point to go to some external space to fill the hole. The truth is more direct. Inflation itself is the reason that he provided a dynamic stage, allowing for the emergence of ephemeral, complex structures, galaxies, planets, and even life. That it's actually because of this stage that will get bigger if there is no expansion. The universe is either immediately shuttle or stop in monotony forever, but it takes us back to where we started. In a manufacturing space, generation time, and at the same time as its own stage in the universe. What does it mean to swell to where? When you ask where is the expansion of the universe going, you're assuming a pre-existing externality. Like a balloon needs air, cities need countryside, but the universe is not a balloon. The universe itself is space. Space is expanding, not into some outer place. It was expanding, created the concept of the outside. Therefore, there is no stage independent of the universe, because the meaning of the outside is defined by the universe itself. This is not a trap of language. It's actually not a shortcoming of the imagination, but the structure of reality is so. Before the expansion. It doesn't make sense to look inward and outward. Expansion creates more space. One side is also generating spatial relationships, established rules. The universe doesn't expand to a certain place, but by becoming more of a universe complete the expansion, rather than invading a so-called non-universe. Following this realization, our understanding of inflation it's actually about moving from mechanical processes to something much deeper. Inflation is like a bootstrap reality. Make yourself from nothing, starting from simple to complex. Every square inch of newly created spacious matter, energy, structure, and complexity open up new possibilities. Universe it's actually not about getting bigger for some predetermined destination. It is capable of accommodating the direction of infinite potential. That we're not in a spaceship, passengers who are taken to a certain place. We are this, part of the self-creation process. Our consciousness, questions, and curiosity. It's actually the way the universe sees itself. The expansion we see is not separate from us, because we are part of that expansion. We are space, time, matter. Complex patterns of self-organization with energy. Ask the meaning of oneself. Starting from this perspective, the superficial inconsistencies are resolved. Meanwhile, a deeper mystery emerges, because the universe can create space and time, both the stage and the audience. That means existence may be stranger than any science fiction. Perhaps we live in a self-created world that's self-sustaining. Beginning and end. In the process of no inside and outside, the universe is expanding towards itself. Make infinite space for infinite possibilities. And for beings like us, vacate a place. Looking back at the questioning along the way, the problem takes us through explosions in dark energy, the multiverse and the quantum bubble, the beginning and end of time. And the most precious answer is actually right in front of you. The universe increases the number of possibilities. Let's get that straight. And so, as we walked all the way here, I just found myself facing never just a cold cosmic model. He is both the expanding void, and we were born, the full stage for thinking doubt. Like the question at the beginning if the universe had rules. Is he a product of order or a chaotic accident? Maybe we don't have an answer yet, but it doesn't matter. Because of the search process. It is the meaning of human existence in an endless time. We've only just turned the first page.